Hello everybody, here we are in section 6.4. We're going to be talking about how to analyze polynomial graphs, polynomial function graphs. So we're going to use this technique. We're going to graph by hand. We're going to graph also by, using our TI Inspire. I like doing this. It kind of makes me dizzy, and I've always wanted to do this. It's cool, isn't it? Anyways, we are going to look at finding zeros of a polynomial through the calculator and by hand through a graph. And also we're going to talk about how to find maxes and mins, and then we're going to call them relative maxes, relative mins for our different problems. So here's the title page. Let's get going. So what you have in front of you is the title page I just told you about. You should be able to graph a polynomial function by hand and on the TI Inspire, locate the zeros, and find the relative max and min. So here's your first slide. Graphing a polynomial. Let me hold this a little bit steadier. If they give you a polynomial f of x, as you see at the top, they have actually also given you a table. So now these tables, or this table in particular, the x values, they chose themselves. Okay? So what they've done is they've branched off of the number 0, and they've gone negatively and positively 0.5 at a time. And when they plugged it into their equation right there, for say 0, 0.5, 1.5, they've gotten all these values that you see here. That's why the squiggly lines say approximately 41, negative 41, approximately 1.8. So all of these are different points. They've got quite a few. They've got 12 points. So what they do is they take those points and they put them right here on the graph. Okay? We're not necessarily going to have to do this because the calculator is going to be able to give us some very good points, and I'll show you how to do that in a moment. Let's look at some other details for this. We want to think about the even degree idea. So when we look back at our, I'll zoom out a little bit, our problem is x to the fourth, negative x to the fourth, but it's an even degree. So you see in the graph how both the endpoints are going down, but they're both doing the same thing. That's important. The middle one, negative leading coefficient. Well, the negative, or the leading coefficient is negative, so therefore both of our endpoints are going down. And then lastly, it's a fourth degree, so you see a maximum of 4 zeros. And we see 1 and 2 over in our problem. So you see 1 right there, and 1 right there. So we're going to move on, but that's one example. And so we're going to make a table, and we're going to graph this and answer any other questions that come around. Alright, so here we are. Locating zeros of a function. Our function is negative x cubed minus 4x squared plus x, or plus 5. So I want you to recall a few things. One, your degree. Recall that the degree of the function is also the max number of zeros it can have. And then also remember that zeros are the same thing as solutions, roots, x-intercepts, alright, answers. So a couple of things for this function, just reminders. It's an odd degree, so the end behavior is the opposite. So they either start high and end low, or start low and end high. We'll talk about this one. It's a third degree, so you're going to have 3 possible real zeros. And it's a negative 1 in the front, so therefore it's going to start high and end low with its arrows. So I'm going to go over here to our calculator, and I'm going to type this one in. Okay? So you can see on here I've got this big screen. I'm going to go to the graph, and I'm going to press tab F1. I'm going to put in negative x cubed minus 4x squared, and then plus 5. And press enter. And there's our graph. So you can see how it starts up on the high end and ends up on the low end. I see 3 zeros, and we see those at, let me see if I get my finger in here, 1, 2, and 3. So what I'm going to do here is I'm going to go use the trace function. If you press menu and you go to number 5, oh, I missed it. Oh, missed it again. Let's just press number 5, trace. And I'm going to choose number 1, graph trace. So my cursor immediately stands at the peak. It's actually on the y-intercept, and the y-intercept turns out to be a spot up there at the top. But if we go back to our question real fast, I want to locate the zeros of this function. So I'm going to go over here, and I'm only going to be concerned about the points that are zeros. Alright, so I'm going to press to the right, and I'm going to go find one. Alright, there's one. So I'm going to jot down 1, 0 on my paper. And I'm going to go over here again, and I'm going to press to the left. Until I get to another one. Alright, there's one. Negative 1.38. So the book is asking you to kind of find like consecutive integers. Well, that's not necessary when you have our technology. So in class with our technology and on quizzes and tests, we're going to use what we have available. Now in this one, I hope everybody sees that the y value is 2e to negative 12. Well, that is actually a really small decimal, and it's close enough to 0 to count it as 0. So we're going to count this as negative 3.62. Alright, so I'm going to go back over. That's all of them. I'm going to go back over to my paper, and while I've been doing this, I wrote those down. So my roots are those 3 roots for this problem. Alright, and that's as many as it can have because it's a third degree. Alright, so let's scan on down here to the bottom. So the maximum and minimum points, this is important. So we just talked about zeros. Let's talk about where the curves are located. If you look in the top left graphic, I've got a picture of a cubic graph, actually, one we just kind of looked at. And you see relative minimum at point B. Well, you know, we talked about in parabolas how things are going to have like a max or a min. Well, in these polynomials, sometimes you have both. And sometimes you have more than one of the same. So we're going to call them relative maximums, relative minimums. So, because in their vicinity, they are a minimum. So it's relative to its area. You can see the definitions in the highlighted region. You can read that to yourself. And down here at the bottom left, you see that a polynomial with a degree greater than 3 may have more than one relative max or min. So understand that. And then the definition of a turning point. The relative max and mins on a graph. So anytime it turns, you should have a max or a min. Now, I wanted to highlight this as well, that when f of x is increasing and it changes over to a decreasing, it has a relative maximum. When it's decreasing and then begins to increase, you just passed up a relative minimum. And we'll talk about that. These are called extrema. So this little highlighted word right here, max and mins are known as extrema. Alright? So, what I have here is a problem that you're going to be given on your homework. It's going to be like this one. So graph each function by making a table of values. Well, I'm going to go ahead and graph it, and I'm going to go find some values. So let me go ahead and get into my calculator. And I'm going to go over here. And it is a 2x cubed minus 4x squared minus 3x plus 4. Alright, so there is my equation. So I'm not going to graph that yet. I'm going to get some points. So I'm going to go to menu, and I'm going to press number 5, trace, number 1, and I'm going to start scanning. So I'm going to go over here all to the far left though first. Well, went too far. There's one. Alright, so negative 1.08. Alright, move over to the right again. I'm just going to wait till I get really good points. 0.4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4. 4 0.812. That's a 0 again. 1.64, this is a weird one. 1.64 and negative 2.86. Alright, and then now we have an E right there, so that's really just 2.27. Alright, that looks like I've got enough. So here's what I was doing as I did that problem. I wrote down all the points that I just gathered. So what I'm going to do is I'm actually going to jot these down on the graph. So bear with me if I'm shaking a little bit. Negative 1.080, that's going to be about, we'll say right there. And then I'm going to have a 0 and a 4. So 1, 2, 3, 4. And 0.8120, so that's almost at 1. And 1.64, negative almost 3. So 1, 2, 3, so about right there, kind of. And 2.27 and 0. And so we already knew it's the third degree, and it's going to be rising, so on the beginning. So it's going up, it comes back down, hits that one, and we're off. So hopefully you get the idea. Let me turn it back to where it's more straight. So that's one of the looks you're going to do. So that's part A. Part B says determine the consecutive integer values of x between which each real zero is located. Well, I could rewrite these, and I would like for you to do that, but that's a root. That's a root. And that's a root. So you would write those down maybe in this space right here as roots or zeros. And so we don't have to worry about the consecutive integer part. We're just going to write down the ones that are straight away zeros. We have the exact answers. All right. Part C, estimate the x-coordinates in which the relative max and min occur. Well, that's these. So that's part C. So one occurs at 0 and one occurs at 1.64. Alright, your last question is a little easier. You don't have to graph it on the calculator. Part A, estimate the x-coordinate of every turning point and determine if those coordinates are relative max or relative min. So what you could do is put down max and min and just label the points where you think that's happening for the x values. So you're going to pick one, of course, right here, right here, right there, there, and then you're going to have to go a little further over, maybe there. So all those marks are going to be turning points, so you can write those down. We'll talk about this in class. Part B, estimate the x-coordinate of every zero. Well, wherever it touches the x-axis, that's a 0. So that one, that one, that one, that one, that's probably 2, and that one, and then the last one over there. So it's got several. Part C, determine the smallest possible degree of the function. Man, this has got a lot. So I've got how many turns? It's going to be an even because everything's going up. So we'll talk about that in class. And then part D, determine the domain and range of the function. Well, domain is always all real numbers. And range, it looks like I'm going to need to know this bottom part. So it's going to be everything above that bottom point. So 1, 2, 3, 4, 5. Maybe every f of x must be greater than or equal to negative 5. All right? We'll talk about this problem in class. So I've kind of ran through the calculator, ran you through some problems. Basically, guys, we've got to make sure that this stuff is in our brain. We've got to know all these details about polynomials. So we'll talk about it. Most importantly, though, remember, always flip and don't flop. You see what happens. And there's your homework assignment or your classwork, whichever way you're going to say it. All right. Good to see you, and we'll talk about any problems you have in class. Adios.